Hello everyone, I'm Jake. In this update, I've organized the workflows I've shared. I created 3 subdirectories. The first is the image-to-model directory, which adds one-click generation workflows for ComfyUI 3D version 2.1. The second is the image generation directory. Added the Quen workflow, which includes LoRa, ControlNet, and edit functions. The third is the video generation directory. It's divided into 2 subdirectories for WanVideo versions 2.1 and 2.2. The WanVideo 2.1 directory also includes workflows adapted for WanVideo wrapper version 1.1.8. Additionally, this update adds a series of workflows for batch generating videos based on scene cuts. This will be the main focus of the introduction. Because ComfyUI's workflow template page cannot obtain the workflows in the subdirectories of the custom node workflow directory. So you have to customize your user path by adding the user directory command parameter when running ComfyUI. And copy these workflows to the workflows subdirectory in your user path. This way, they can be loaded anytime from the workflows menu. We know that WanVideo 2.2 requires a 2-step generation process with a high noise model and a low noise model. And the most critical parameter is determining at which step to switch. ComfyUI provided a quick method. Directly connect the step output from this node to the end step of one sampler and the start step of the other sampler. Generally, switching at a sigma value of 0.9 yields good results. This is very convenient, but it's not suitable for the native sampler. If you don't use the sigma value for control, then you have to manually input the step switch value. For a total of 12 steps, the step switch value is approximately 5. So, what is the relationship between the sigma switch value and the step switch value? You can see the relationship between the two through this node provided by ComfyUI. A schematic diagram appears after running it. With the current settings, a 0.9 sigma switch value corresponds to a step switch value of 5. If the shift value is increased, the step switch value becomes 7. Different total steps, schedulers, and shift values result in different step switch values. Because the sigma to step node cannot be directly connected to the native version sampler, ComfyUI also provided a solution. By connecting a dummy model node and a basic scheduler node to the sigma slot, you can obtain the step switch value for the native process. Note, after connecting the basic scheduler node, the sigma's output contains a data, and the parameters in the current node will not take effect. Let me demonstrate. The native version scheduler includes a denoise parameter, which is different from the WanVideo wrapper. If we lower the denoise value in the basic scheduler, we can see the output sigmas also decrease. Okay, let's look at the method for switching between the high noise and low noise models in the native process. We use the step switch value from the split sigmas node to control the number of steps for the high noise model and the low noise model. This dummy model node is only for quickly obtaining the step switch value. When actually used, you still need to connect the real model. For example, let's connect this WanVideo model and compare the results. After generation, you can see the sigma value for the second step change from 0.9822 to 0.9888, and the sigma values for other steps are also different. Although the difference is very small, when actually using it, you still need to connect the real model, not the empty model. Next, let's introduce an advanced 3-step sampling scheme. I'll label the steps first for easier understanding. The first step samples two steps called the first touch, using the high noise model and a high CFG value. The second step samples three steps, which is the step switch value minus the first touch value. 5 minus 2 is equal to 3, using the high noise model with a CFG of 1. The third step samples 7 steps, which is the total steps minus the step switch value. 12 minus 5 is equal to 7, using the low noise model with a CFG of 1. I merged the multi-samplers into a subgraph for ease of use. First, let's look at the native basic subgraph. The basic scheduler defines the total steps, and the split sigma step is the switch step. It generates the sigma values for the high noise model and the low noise model respectively. The first sampling step adds noise, while the second sampling step does not require adding noise. The advanced version of native sampling is divided into 3 steps. The first sampling step adds noise. The second and third steps do not add noise. The samplers are switched using 3 values: total steps, first touch step, and switch step. The first sampling step typically uses 2 steps, the high noise model and a high CFG value. The sigma values for the second sampling step are obtained by performing a secondary split based on the first split. I don't use the lower sigmas from the second split for the third sampling step. Instead, I obtain them via another basic scheduler sigma split. This allows independent control of the denoise value for the third step. The basic version is controlled by the total steps and switch step, with only 1 CFG and 1 denoise setting. The advanced version is controlled by the total steps, first touch step, and switch step, with 2 CFG and 2 denoise settings. For the WanVideo wrapper sampler, I also created 2 versions of subgraphs. However, the internal setup is slightly more complex, divided into 2 scenarios. One scenario is when the denoise value is 1, and the other is when denoise is less than 1. I will analyze this shortly. Additionally, although some features currently cannot be used in WanVideo version 2.2, I have kept their interfaces, such as multi-talk, fantasy talk, etc. The advanced version has an additional high CFG step. Instead of using 3 samplers, this is implemented within 1 sampler using a scheduler or CFG list. Let's preview its output values to understand. In the first 2 steps of the first touch, the high CFG value for the first touch is used. In the subsequent steps, the second CFG value is used. By looking at the code for the WanVideo wrapper sampler, we can see that when denoise is less than 1, it is achieved by increasing the start step, or in other words, reducing the total number of steps. Therefore, there is a restriction. The original start step must be 0. The start step for the second sampler must be 0, which is different from when denoise is 1, where the value is the switch step. Furthermore, from the formula for the start step, we can see that when the denoise value is larger, the start step is closer to 0. When the denoise value is smaller, the start step is closer to the total number of steps. Therefore, for the steps parameter of the 2 samplings, you cannot simply use the overall total step value. You must use the actual number of steps. On one hand, this is necessary to accurately calculate the current sampling steps based on the denoise value. On the other hand, because when the denoise value is small, the start step might be greater than the end step, which is not allowed. For example, with a total step count of 12 and a denoise value of 0.3, the calculated start step is 8, but the end step is only 5. Next, let me introduce a very important node in this update: scene cuts. You can use it to set the duration or edit points for each scene, acting as the master controller for batch video generation. FPS stands for frames per second. Segment frame count indicates the maximum number of frames supported by the video model for each generation. WanVideo supports 81 frames. Skyreal V2 supports 97 or 121 frames. When the WanVideo wrapper processes reference image to video, the first few frames of the video record the reference image batch, which we don't need. Warm-up frame count can be used to exclude these preparatory frames. This is especially important when handling lip sync. During the warm-up period, you need to add silence or a preceding audio track to the audio. When the frame count of a scene exceeds the segment frame count, overlap frame count controls the length of the overlapping section between consecutive video segments in context windows or for loop processing. When min loop frame count is set to duration, the duration of each video segment is calculated based on its actual length. If set to segment, then the duration of each video segment must be the segment frame count. This prevents quality degradation caused by segments that are too short. However, testing showed it's not very necessary, especially since there are overlapping frames from previous segments. It also adds unnecessary complexity for scene control, so this parameter is temporarily disabled. There are two methods for long video generation. One is using context windows, the other is using for loops. Each has its pros and cons. Based on my tests, the best method for first frame video generation is using the native workflow's context windows. For text-to-video and reference image-to-video generation, using the native or wrapper versions for loop is recommended. The mode parameter includes two options, duration and cut points. When mode is duration, the value list entered in the segment window represents the duration of each segment in seconds. When mode is cut point, the value list entered in the segment window represents the time of each cut point in seconds. Generating videos continuously places very high demands on hardware, so you can use select cuts to choose which parts of the defined segments to process currently. For example, if we enter 4 segments and the current processing segments are 0 to 3, that means all 4. Let's run it and take a look at the scene cut data. There are 4 scenes in total. The frame count for each scene clip is 80 or 64 frames. However, the frame count for each loop, which is the actual frame count during generation, is slightly different. WanVideo generation must follow the formula value of n multiplied by 4 plus 1. The total frames of scene cuts are 288, 18 seconds, while the generated frames are 292 frames, 18.25 seconds. If you readjust the duration, the corresponding scene cut frame count and loop frame count will adjust accordingly. The for loop must ensure that each segment follows the formula value of n multiplied by 4 plus 1. The context window is 1 loop, and the total frame count must be the formula value of n multiplied by 4 plus 1. Even when using the long video generation method, I just recommended. Using a for loop might cause color shift, while using context windows might lead to jumpy transitions. This is still something to pay attention to. In a previous video tutorial, I suggested using WanVideo version 2.1 with a for loop under the WanVideo wrapper version 1.1.8 environment to generate long videos. If you're interested, you can give it a try. This is the basic usage of the scene cuts node. Note that if you add an audio input to the scene cuts node, then the scene cut data will automatically adapt to the audio duration. First, let's play the music.
On a bright sunny day, the birds start to sing as the gentle breeze blows it down.
After running it, you can see the total duration and total frame count in the scene cuts data are updated accordingly. Besides controlling video generation, the scene cuts data is more importantly used for audio editing to adapt scene audio and lip sync voice audio. I provide 4 audio editing tools. This cuts audio editing node can synthesize the audio for the corresponding scenes into a single track based on all the scene cut data. For example, the 3 scene cuts numbered 2 to 4 plus the overlap frames total about 25 seconds.
Yeah, it's like a symphony of nature everywhere. The sound of the waves is on my skin. I feel the warmth of the sun filling up the waves, crashing along the shore. The rustle of leaves as they fall to the floor.
This index audio editing node can select a specific segment from the scene cuts to generate the corresponding audio, including the warm-up frames.
This is on my skin. I feel the warmth of the sun filling up the waves, crashing along the shore. The rustle of leaves as they fall to the floor.
This loop audio editing node can generate the corresponding audio for a specific loop within a segment. It automatically pads the last loop with mute to ensure each loop length matches the segment frame count. There's also another node here that allows you to manually input start and end times to edit the audio.
On a bright sunny day, the bird.
Adding start or end mute allows you to add mute to areas beyond the audio duration.
On a bright sunny day, the birds start.
This set of audio editing tools can work together to accomplish complex batch audio-video generation. The one I'm opening now is a scene cuts workflow using WanVideo 2.2 version Fun Inp. Please note, WanVideo 2.2 currently does not have a multi-talk tool. Add audio control as needed. The current setup includes 12 scenes, each 8.8 seconds long. Please note, the current workflow supports a maximum of 12 scenes. Of course, you can add more based on your actual situation. You can see I have provided corresponding prompts and start frames for each scene. You can also control more sampling parameters. The model selection uses Fun Imp's high noise model and low noise model. For LoRa, select the corresponding Light X2V low step model along with the MPS and HBS dynamic enhancement models. The default total steps is 12, switching model sampling at step 5. The settings for the native solution are the same. The generation process includes 2 sets of for loops. The outer loop is used to switch between selected scene cuts. The nested loop is used to generate the for loop long video. It is only enabled when the long video method is set to for loop. Otherwise, it switches to the context window subprocess. There are 3 context windows here because the advanced native sampler subgraph has 3 model inputs. Besides the high noise and low noise models, for the first touch sampling, you can also choose whether to add the low step LoRa. In this switch node, selecting 1 means using the low step LoRa. Selecting 2 means not using it. This feature is only for the native solution. I have already explained the parameter settings for the subgraph in a previous video. The advanced version of the subgraph is used by default. Alternatively, you can use a for loop to generate the long video. The settings in the wrapper solution are identical. They include the choice between basic and advanced versions, and the choice between context window and for loop methods. How to use multi-talk or infinite talk. This is already embedded in the corresponding scene cuts workflow for WanVideo version 2.1. There is an additional node for separating vocals. In the multi-talk setup, use the index audio editing node to load the audio for the corresponding scene cut. If using for loop long video generation, then use the loop audio editing node to load the audio for the corresponding loop. For videos generated with WanVideo version 2.2, you can use this talk version of the scene cuts workflow Using video repainting to achieve lip sync. For each scene cut, besides the start frame, the corresponding original video is also added. This allows the workflow to automatically load the corresponding original video for each selected scene cut, encode it, and perform video repainting. Regarding the method of using video repainting for lip sync, if you're interested, you can watch my previous video. Finally, let's look at some generation examples.
On a bright sunny day, the birds start to sing. As the gentle breeze blows, it dances on my skin. I feel the warmth of the sun filling up the air. It's like a symphony of nature everywhere. The sound of the waves crashing